Integration by parts, partial integration, one of the important methods in integration. Here, the part of integrand to be differentiated is usually denoted by the letter u, small letter u. The part of integrand to be integrated is denoted by the letter dv. At the same time, you will differentiate as well as integrate. Therefore, you have to select u and dv properly. Selection of u and dv plays an important role here. Therefore, you have to remember the table always. Try to remember this and try to recollect this correctly. Now, this integral, our first type. Here we have integral x power n e power x dx, integral x power n a power x dx, integral x power n sin a x dx, integral x power n cos a x dx, etc. In these cases, you take u as xn. You differentiate this. And again you take dv as the remaining. Here integral x power n e power ax dx. If you take u equal to x power n, the remaining is e power ax dx. Therefore, take it as dv. Next, second one, integral x power n a power x dx, x power n take u as x power n and a power dx as dv. The third one, x power n sin ax dx, you take u as x power n, dv as cos sin ax dx or cos ax dx, these two. Now come to type 2. Here integral x power n log x, don't forget, this is log x and inverse functions, sin inverse x, cos tan inverse x, same one x power n, but instead of e power x, a power x, sin ax, cos ax dx, here we have log x sin power in sin, that is sin inverse x, tan inverse x. Here it changes. Be careful, u and dv changes. Here in the place of u, you take log x, sin inverse x, tan inverse x. Remember this, and dv, just you take x power n dx, that's all. Right? Now 2a. Here there is no x power n, that is integral log x dx, sin inverse x dx, integral tan inverse x, same as the previous one. That is, you take u as log x, sin inverse x, tan inverse x, etc. and dv as here there is no x power n, therefore dx. Now third one, say here integral root of a squared plus x squared dx, a squared minus x squared dx, integral root of x squared minus a squared dx. You take u as the square root and dv as the remaining dx. Now fourth one, integral e power ax sin bx dx, integral e power ax cos bx dx. Very good. As you like, you can take anything. U as e power ax, dv as sin bx dx, or u as e power a sin bx and dv as e power x dx. It is left to you. The last one, substitution method. Follow any method after substitution. That's all. Now here important formula, only one, we are going to use only one formula. That important formula to be used is integral u dv equal to uv minus integral v du. Don't change. Integral u dv equal to uv minus integral v du. Integration by parts type 1. Problem number 1. Evaluate integral x e power 2x dx. Here in type 1, if you have like this x or x power n e power 2x or 3x dx, then in that case you take x as u, it is u equal to x, differentiate this, du equal to dx, isn't it? Next, v, dv equal to, it is leave this x, dv equal to e power 2x dx, isn't it? Therefore, integral dv equal to integral e power 2x dx, that is equal to 1 by 2 e power 2x, e power 2x by 2, that is 1 by 2 e power 2x. Come to step number 2, integral u dv, the standard formula, equal to uv minus integral v dv implies integral u is x, dv is e power 2x dx. That is the given problem, equal to uv, u is x, v is 1 by 2 e power 2x minus integral v dx, v is 1 by 2 e power 2x dx. Is it clear? Now this is equal to integral x e power 2x dx equal to, look at this, here we have x e power 2x by 2 minus 1 by 2, you look at this integral e power 2x dx. Again we have, already we are left hand side we have integral. After reducing this, in the right hand side also we have an integral e power 2x dx. This integral must be easier than the first integral. Here e power 2 x e power 2x dx. That is why we require this method, integration by parts. Here we have only one, not x or anything. Therefore, this is very simple method. That is, integral e power 2x dx must be easier than the given integral. Suppose if we have x squared, integral x squared e power 2x dx, then the problem is cumbersome. It will go on. There will be no end. That is, here the problem is integral x e power to x. You reduce by integration parts by parts, we get the integral. This must be simpler than this. It should not be x squared e power to x or x cube e power to x. Is it clear to you? That is why integral e power to x dx, then the right hand side must be easier than the left hand side. Clearly it is very easy because we can directly integrate this plus c. Problem number 1 is over. Now come to problem number 2. X cos 3x. Again, integral x power n cos ax or cos bx. If you have in the first type u equal to x, therefore du equal to dx, differentiate here. Here remaining after x we have cos 3x dx. You take this as dv. Then integral dv equal to integral cos 3x dx. What is integral cos 3x dx? That is sin 3x by 3. Now apply the formula. Integration by parts, we have integral u dv equal to uv minus integral v du. That is, this is equal to integral u is what? X. dv is cos 3x dx. Left hand side, that is given problem, is equal to uv x. v is what? Sin 3x by 3 minus integral v is 1 by 3 sin 3x. dx is du is dx. Very simple. That is 1 by 3x sin 3x. Now you integrate this. Sin 3x becomes minus cos 3x by 3. That is cos 3x by 3 plus c. That's all.